In this lesson on exponential and logarithmic equations, we'll use the common logarithm or the base 10 logarithm to solve exponential equations. Here's our first problem. We're asked to solve the exponential equation 7 to the x equals 45. So the first thing we'll do is rewrite this exponential equation in logarithmic form. In logarithmic form, we solve for x to obtain that x is equal to the log base 7 of 45. Now we'd like to get a decimal approximation for x, and we noticed again that we don't have a log base 7 button on our calculator, but what we can do is use this change of base formula that we've derived previously to express the log base 7 of 45 in terms of the common logarithm or the base 10 logarithm. So using our change of base formula, this becomes log 45 over log 7, where again, these are your base 10 or common logarithms. You can now use the log button on your calculator to do log 45 divided by log 7, and to 3 decimal places, we get that x is approximately 1.956. We can check that this makes sense by computing again on the calculator 7 to the 1.956, and we do get approximately 45. Moreover, as you're solving these problems in general, you should think about doing quick in your head calculations to make sure that your answers make sense. We notice that we get for x approximately 1.956, which is a little less than 2. 7 squared is 49, which is just a little higher than 45, so as a very quick check, 1.956 makes sense for x. So again, the key to this problem was to first write our exponential equation in logarithmic form, and then use our change of base formula to get our base 7 log in terms of a common log. Let's do one more problem. Here we have the exponential equation 0.3 to the x equals 2.4. Again, our first step will be to solve for x to write this equation in logarithmic form. So we get that x is equal to the log base 0.3 of 2.4. To get our decimal approximation for x, we'll use our change of base formula. We get that this is equal to the log of 2.4 over the log of 0.3. And using our calculator now to get a decimal approximation, we get that x is approximately negative 0.727.